I'm going to go over the concept we call acceleration. Acceleration is change of velocity with respect to time. So, main objective is to help a student discover two misconceptions. Number one, can the acceleration be positive when the velocity is 0? Yes. Can the acceleration be 0 when velocity is positive? Yes. All right. So, our main objective and goal is to discover these two misconceptions. So, let us get started. As usual, I am going to start with something let's say 75 kilometer per hour, and we are going to convert it to SI unit. So, let us see how it goes. So, kilometer has to be down and meter has to be up, because the SI unit for kilometer is meter and the SI unit for hour is time is of course second, not hour. All right. So, now hour has to be cancelled, now second. All right. So, this is the SI unit for distance, this is SI unit for time. So, 1 kilometer is 1000 meter and 1 hour is 3600 second, of course. Now, you have hour cancel, you have kilometer cancel. What are you left with? You are left with 75,000. All right, a meter over 3600 second, and that gonna be 0 cancel. So, about 750 divided by 35, which is 36, 20.8 meter per second. So, this is not SI unit, however, this is SI unit. SI unit for what? Velocity. Okay, good. Now, let us see question number 2. If you have 15 kilometer per hour per second, and what would be the SI unit of this? Let us discover it. So, 15 kilometer per hour per second, this is how you can write it, but I often put 1 over here so that you can use the algebra. What algebra we are referring to? A over B over C over D is A over B times D over C. This algebra you can apply over here, become like Einstein. Let's hold him with respect. All right. All right. Okay, so this is going to be 15 kilometer per hour times 1 over second, right? So, we basically get 15 kilometer over hour times second. Now, problem with kilometer and hour, they are not SI unit. We have to convert them to the SI unit. We already know how, because kilometer has to be here, meter has to be here, hour has to be top, second has to be in the bottom. So, 1 kilometer, 1000 meter, 1 hour, 3600 second, kilometer cancel, hour cancel. What are you left with? 15,000 meter over 3600 second times second square, which is 4.2 meter per second square. All right, very nice. Good. So, now I am going to give you a problem to understand, to discover two misconceptions we discussed earlier. Misconception number 1 will be removed by this problem. Let us say I have a car moves, car is at rest, so velocity is 0, right? Good. But at location 2 or scenario 2, the car is 1 second. What would be the velocity? At location 3, the car is, let's say, 2 seconds. What would be the velocity? And location at the end, the time, let's say 5 seconds, and velocity final, let's say 75 kilometer per hour. All right, good. What I want you to do is scenario Scenario 1, scenario 2, scenario 3, scenario 4. Scenario 1, 2, 3, and 4. Okay, so far so good, right? So good. Now I want you to write the time. Time for scenario 1 is 0, time for scenario 2 is 1, time for scenario 3 is 2, and time for scenario 4 is 5, and time is in second. I want you to find the velocity, which is in meter per second. I want you to find the velocity, which is kilometer per hour. I want you to find the acceleration, which is meter per second square, and I want you to find the acceleration, which is kilometer per hour per second. All right, so let's do it. Okay, so 1, 2, 3, 4. All right, we can do it a little better. All right, good. So far, so good. All right, velocity. Okay, so before we do velocity, let's do the acceleration. What is the acceleration? 4.2. Or we can say that acceleration, we can find it. Acceleration is velocity final minus velocity initial over t final minus t initial. What is the velocity final? 75 kilometer per hour minus b initial 0. Put a initial. T final 5 seconds minus 0. So you have 15 kilometer per hour per second. And 15 kilometer per hour per second, we did it before, is 4.2 meter per second square. Good. And 75 kilometer, we did it before, convert it to SI unit, 20.8 meter per second. Excellent. Come over here now. Acceleration is, what is the acceleration? 4.2 meter per second square. Now let's explain. When you go to the car, right, you turn on the engine, right, and you carefully put your right foot on the gas or accelerator if you drive Tesla. If car doesn't move, car velocity has to be 0, right? If it doesn't move, its velocity is 0. But acceleration is not 0. It is acceleration that give the rise to the velocity. If the acceleration is 0, then there would be no velocity and the car would never be moving. So in order for car to start moving, there has to be acceleration. Good. All right. So what is the acceleration? Acceleration is constant throughout the process. Acceleration is constant in SI unit. Or in kilometer per hour per second is 15, 15, 15, 15. They both are the same, by the way. Okay. So let's talk about 15 later. Let's just pay attention to 4.2. If it is 4.2, what is the velocity? Velocity is 0, right? However, since acceleration is positive, velocity would be what? 4.2. Now you can use Vf is equal to Vi plus At. And you see, my friend, Vi is 0. So Vf is 0 plus A is 4.2 meter per second squared. And T is 1 second. Second square second. So you have 4.2 meter per second, and that's what you got. All right, now let's see this one, 8.4. How do you get 8.4? Again, Bf is equal to Vi plus At. This is 0, so Bf is equal to A is 4.2 meter per second squared times 2 sec. Second goes to second square once. So you have 4.2 times 2, 8.4 meter per second. All right, now you know the last one. Last one is, of course, 20.8. You can check it by this one. No problem. If you use this, However, if you use the kilometer per hour per second, and velocity, acceleration would be also constant, then and at the 1 second it's going to be 15, at 2 seconds is going to be 30, and then 4 seconds is going to be 75. So hopefully you understand that even when the velocity is 0, acceleration doesn't have to be 0. Hopefully now you are happy because you discovered one misconception people carry around. Now let's understand the other misconception, and that is, can the acceleration be 0 when velocity is positive? Of course, of course. So that take us problem number 3. Problem number 3, I'm going to give you 4 scenarios. You have to be correct in terms of grammar, but nobody cares about grammar in physics. Okay, so you have scenario 1. All right, you have scenario 1. The car is moving to the east. Scenario 1. Scenario 2. The car is still moving to the east. All right, scenario 3. The car is moving to the west. Scenario 4. The car is moving to the west. All right, so far so good. Now this is west, of course. This is east and this is east. All right, so what are you going to do now? I'm going to put some more information for you to solve the problem. So let's say the car is moving at 2 meters per second, 4 meters per second, 4 meters per second, 2 meters per second, 4 meters per second, 2 meters per second. No, let's say 2 meters per second, 4 meters per second, 4 meters per second, 2 meters per second. All right, one more thing before I let you go, and that is, let's say time is 0 here, time is 0 here, time is 0 here, and time is 0 here. And let's say time is 1 second here, 1 second here, 1 second here, 1 second here. That means the elapsed time is 1 second. The car moves for 1 second. All right. Let's see how much physics you can get from here. All right. So you have it here, and then you have it 1, 2, 3, and 4, right? 1, 2, 3, and 4. Okay, let's see. Let's make more room. 1, 2, 3, and 4. Let's write velocity, and let's say velocity either positive or negative. All right. Velocity, then acceleration, either positive or negative. Velocity vector, either east or west. Acceleration vector, either east or west. And then finally motion, either speed up or slowing down. So much physics we are getting from here. So I know you are excited. Okay, so this is moving to the east, velocity is positive. Moving to the east, velocity is positive. Moving to the west, velocity is negative. Moving to the west, velocity is negative. Simple. Acceleration now. Okay, let's find the acceleration here. What did I tell you? Acceleration. Acceleration is velocity final minus velocity initial divided by t final minus t initial. So acceleration is 2 meters per second squared. So acceleration is positive. Report. Let's see acceleration. 2 minus 4 divided by 1. So which is negative 2 meters per second squared. So report it negative over here. Acceleration over here is, now the west means the negative. So acceleration is b final, that is negative 4 minus 2 divided by 1, which is of course negative 2. So negative 2 meters per second squared, and that is negative. And let's do this one. What do we get? Negative 2, negative 4 over 1, and that is negative 2 plus 4, and that gives you positive 2 meters per second squared, and that is of course positive. All right, so velocity vector is of course positive, right? So east, positive east, negative west, negative west. Acceleration vector, positive east, negative west, positive east. Okay, now we're going to make a conclusion. If velocity vector and the acceleration vector are the same direction, speeding up. Opposite direction, slowing down. Same direction, speeding up. Opposite direction, slowing down. And that's today's lesson.